Hello and welcome to section 7.5, which is on proportions in triangles. So theorem 7.4 states that if a line is parallel to one side of a triangle and intersects the other two sides, then it divides those sides proportionally. That is a side splitter theorem. It splits the sides. So I have an example drawn here. It says, what is the value of A in the diagram? And this is an example of this side splitter theorem. It says if I have a line parallel to one side that intersects the other two, so it crosses here and here, then it divides it proportionally. And because we know that it is divided proportionally, I can use a proportion to solve this question then. So I can say that my A plus 4 over A is going to equal my 18 over 12. Just make sure that when you if you start with this side first, that you have to start with this side first on the proportions. So now I'm going to crisscross. So 18 times A is 18A. And then I have to do 12 times A plus 4. So I'm going to have to do distributive property. So 18A equals 12A plus 48 minus your 12. Move it over here. That leaves me with 6A equals 48. Go ahead and finish your last step, which is to divide by 6. So A is 8. Because the side splitter theorem says that if I have that parallel line and it crosses both other sides, it's going to be proportional. I can go ahead and set up a proportion to solve that. So the next one, in triangle XYZ, RS joins XY and YZ. So in other words, it crosses it, so side splitter theorem. And RS joins XY and YZ with R on XY and S is on YZ, so I drew that. That says RS is parallel to XZ. So if YR over RX equals YS over SZ, and that equals 1 when I solve that, what has to be true about RS? Well, the only way that would work is if my proportions were equal. So like if I had 1 over 2 on both sides, if they both reduced. So this is going to be, so RS, R to S is going to be half of X to Z. Because this is parallel, RS right here is parallel to this one, and it crosses both pieces, we know that it has to be proportional. Okay? And we could use the midpoint theorem to prove that. So the midpoint theorem is my reasoning for that. Corollary to the side splitter theorem. So if 3 parallel lines intersect 2 transversals, then the segments intercepted on the transversals are proportional. And so I have a drawing to kind of go with this here. I'm asking what is the length of side C? And C, I didn't mark it, but C is right there, that piece. And so we can use what's given. This side right here, I have both pieces to it, so I can use that for my proportion. So 8 over 7.2 is going to equal 6.4 over C. And then I just have to crisscross. So 8C equals 7.2 times 6.4, which is 46.08. And then I'm just going to divide by 8 for my last step. So my C equals 5.76 yards. Because I know those things have to be proportional, using this corollary, if 3 parallel lines intersect 2 transversals, so I have a transversal here, and then I have parallel lines there. So the segments that they make have to be proportional is what it's saying. That's why I can use this proportion to solve this. Theorem 7.5 says it's a triangle angle bisector theorem. It says if a ray bisects an angle of a triangle, bisects means it cuts it in half equally. Then it divides the opposite side into two segments that are proportional to the other two sides of the triangle. And let's just assume that my drawing is perfect and that it looks like it's perfectly bisected there. I suppose I should have drawn this in here to show you that those two things are equal. So now, because I know that that is equal, I can set up a proportion to solve this. So 9.6 over 16, these two pieces, are going to equal y over 24. So now I can crisscross, so 16y equals 230.4 divided by 16. So y is 14.4. I don't have a label, so just leave it 14.4. If a ray bisects an angle of a triangle, which is what's happening in that picture, then it divides the opposite side into two segments that are proportional to the other two sides. And that's why I can set that up that way. Okay, the whole thinking of this whole chapter has been, how do I prove proportionality? So bring that knowledge with you, and we will talk about it more the next time I see you. Have a good night.